second midterm practice exam, problem 3. In which direction does the magnetic field B point at this point P here, where these two blue lines here are current carrying wires? This is a problem that is asking about the Biot-Savart law, and the Biot-Savart law has this condition, that the magnetic field from a current element, so if I just look at one little tiny piece of that from a current element, is going to be dl cross r hat over script r squared. There's some other stuff, so proportional to, I should write, not equal to. And so r in this case is this distance here. This is our little script r. And we can find out the direction from the right-hand rule here. So the direction of the current element, that's this way. The direction of r hat, which is actually points, r hat points from your source actually to the point you're looking at. So r hat actually points the other way, not that end, points this way. So we have direction here, current, and so the magnetic field is going to point inward due to this part right here. And its strength depends upon 1 over r squared. And so now we compare that with a section from this one here. And again, this is going to be r hat here. In this case, the current points along there. The magnetic field is going to point up. So I have a magnetic field pointing down from the top wire and a magnetic field pointing up from the bottom wire. And now I need to somehow compare sizes. I know I have the same current running through each wire, so that's not going to change. And so I have to look at the contribution from the loops. And what I see is that the strength of the magnetic field decays as 1 over r squared, but the size of the loop will only go as r. And so the strength of the magnetic field due to any portion of a loop will decay as 1 over r as you get further away. Since this loop is further away than this loop, the magnetic field from here is weaker than the magnetic field from the closer one, and so it's going to dominate, and I'm going to have option C.